Hello everybody and welcome to today's presentation in which I will be talking about one of the most useful construction equipment called dozers. So first question that comes to mind is why are dozers so popular? Why do we see dozers on almost any construction field that has some kind of earthwork? The reason is because they do a lot of different tasks for us, from cutting, compacting, raking, to clearing, stripping, ripping, spreading. All types of different earthwork activities could be done using dozers. Basically, dozers could be classified into two main groups. The first group are the track dozers, and as implied by the name, they use a tracking pad. Okay, let me get my pen here. So they use a tracking pad and not wheels to move on the surface. Sometimes they could be rubber track dozers, and rubber track dozers have triple wheels to rotate the tracking pad in front and rear. On the other side, we have the wheel dozers, okay, which most of us should have seen. So wheel dozers, obviously they have wheels. So when you're comparing track with wheel dozers, you're talking about power versus speed. So track dozers are more powerful. They could move on almost any terrain. They could go up the hill and on almost any surface condition, while wheel dozers cannot go on sharp road surfaces with sharp edges. They cannot work really smoothly on up the hill, and they are more limited in motion. There are some other differences, but before that, let's take a quick look on some of these on these dozers, starting with track dozer. Yeah, here is a track dozer. As you can see, they have a lot of different applications. They can easily move on mud and on poor surface road condition. And despite what you think, the pressure they exert on the field is not that high. In fact, wheel dozers exert more pressure on the field. That's why if you use them where you have a lot of travels, you could actually compact the surface of the road. I'm talking about the wheel dozers. So yeah, here are some examples of track dozers. We can see they are super powerful machines. So let's see this. What are these rubber tracked dozer? So yeah, this one is a rubber track. As you can see, they have a different mechanism for creating the power that is required to move the machine. And finally, the wheel dozer, which is more familiar. Again, one of the most important advantages of wheel dozers is their speed, so they can move a lot faster than track dozers, as you can see. Okay. All right. So with this introduction, how do we know if we need a track dozer or a wheel dozer? So I want to make a decision between the two of them. Wheel dozer work well on firm soils like like concrete or abrasive soil. And if there are a lot of sharp edge pieces on the ground, wheel dozers are not recommended. So they're also very good for level and downhill and not uphill because their engine cannot function really well if you are both going uphill and if you're pushing a lot of heavy materials. So wet weather limits their functionality, and because they create a soft and slick surface on which the machine cannot move freely. So they can offer kind of compaction on the surfaces, especially where there are tons of travels, because the pressure they exert on the surface of the road is comparatively higher than the pressure a track dozer would apply. They are best in handling loose soil, obviously, because they're not as powerful as the track dozers. But yeah, the most important advantage with them is the fast return speed between 8 to 26 miles per hour, which is pretty good. So they can handle only moderate blade loads, not a very high amount of load. On the other hand, we have the crawler dozers. So crawler dozers can work on a variety of trains, let's say on almost any kind of train. But yeah, even they can work on sharp edge pieces. I mean, obviously there is some depreciation. They will wear out faster if you move them on a surface with a lot of sharp edges. But that amount of wear is a lot less than a wheel dozer. Obviously, wheel dozers cannot go on a surface with sharp edge pieces. So they can work on soft ground and cover mud slick surfaces where wheel dozers are a lot less capable, and they will exert a lower pressure so this is compared with the wheel dozers. This might sound to you a little weird, but in fact wheels apply a higher pressure on the road compared with track dozers. Yeah, but they are good for short distances because of their super slow speed, which is between 5 to 10 miles per hour, and they can push large blade loads, okay, compared with the wheel dozers that are limited in the amount of load they can push. So let me just make sure why I don't have, okay, now it is right. So usable power of a machine, if you remember from the previous chapter, we said not all of the force that the machine creates is not usable. The amount of force that is usable by a machine depends on two things: coefficient of traction and the weight of the machine, right? Remember this? So what does this mean? It means to increase usable, let me get my pen here. So to increase the usable force, you need to increase, you can increase the weight on powered running gear. Okay, so you might say, how about the coefficient of traction? Coefficient of traction depends on so many factors that changing them is not easy, but changing the weight of the machine is easier. So the heavier your machine is, the more usable power it generates. So sometimes you can increase the tractive power by increasing the weight of the machine, right? But how do we increase the weight of the machine? There are different ways of doing that. Number one is filling the tires of wheel type dozers, obviously, not the track dozers, with liquid ballast. Okay, it's a mixture of calcium chloride and water. yeah, that does sound, a little bizarre, but that's what people do on the field. So they fill the tires, they fill the wheel tires with this mixture to make the machine heavier in order to increase its usable power. And sometimes you can put steel plates um, on the machine so it will be heavier and the usable force will increase. When you're doing that, you should be careful to, to put, to create a uniform distribution of weight, on different parts of the machine. It means you should maintain a balanced weight. And not one part should not be, heavier, left should not be heavier than the right, or vice versa. Or rear should not be heavier than front, or vice versa. You should have a unanimous distribution of load when you want to make your vehicle heavier. So in this slide, you can see different parts of a dozer. So some parts are more important to know. Most important thing about a dozer is its blade, and there is a variety of blades based on the application you expect from your dozer. So as you can see, you have this cylinder that are using for pitching or for lifting the load, and you have different they are called lift cylinders, and you have the angle cylinders that are used to move the blade to right or left. So we call this part the track pad, okay, and there are different parts. We obviously don't have enough time to get into a lot of details about each part, but since blades are very important, let's learn about the blades, and I expect you to be able to identify a blade when you look at the picture. So here is excuse me, here are the blade. You can see the blade compartments. As you can see, these are the angle cylinders. There's two of them, and these are the lift cylinders. They're very powerful cylinders, and these are attached to the back of a blade and create different, different kinds of motions. So let's start with universal blade. Universal blade can do different types of, earthwork activities. They are good for using for pushing very heavy materials, or when you need to have high penetration work, as you can see. So straight blades, as implied by the name, their straights are their blades is totally straight, so they can they're super powerful machines. They can create a lot of pushing force, and they're suited for granular materials. Okay, so continuing with semi or semi-universal blades, they have shorter wings and combines characteristics of both universal and straight blades. So it's something in the middle between universal and straight blades. So clearing blades are these blades. As you can see on one side they are different. They are used for land clearing. Let's watch a very quick video about how powerful a dozer is in clearing the earth. So as you can see, it can do different tasks. Okay, look at this. As you can see, it can easily fall a tree, okay, in less than a minute. Yeah, it just killed this tree, which is sad, but it shows how powerful it is. Okay, so going back to the slides, yeah, we have cushion blades. They're used to push other scrapers. I will talk about this in details when I teach these scrapers in chapter 8. But yeah, many times we need external or extra power to push the self-loading scrapers, and for that we use cushion blades. You might ask, let me get my pen back. You might ask, doesn't it apply a lot of load when the machine hits the scraper? The answer is we use some kind of pads that absorbs the energy when when the dozer hits the scraper, to start moving it. So it absorbs the energy and you won't feel it that hard. So yeah, they're called the resilient pads or some other form of cushioning materials, which absorb shock loads when the blade comes in contact with the tractor. Okay, we have dozer blades, or bulldozer blades, and remember they're different, their spelling is different. So bulldozer is a bottomless high capacity blade. It's super big, and it's used for lightweight work like wood chips. Okay, as you can see, the capacity of that could be quite big. So angle blades, they are broken. They're good for broken and granular materials, soils and gravel. They're also good for digging drainage ditches, backfilling trenches, and grading roads. And V-blades. V-blades are also interesting. They are used when you need a lot of energy to go forward. Okay, where there are a lot of objects that hinder the machine's movement. For example, when you're moving in snow. Let's watch a quick video about how they operate in the snow. So as you can see, they're super powerful. If I can get a good view, yeah, you can see the V-blade here. Yeah, here it can be clearly seen. And as you can see, the height of the blade could be a lot. So it can create a lot of pushing power. Okay, moving on from V-blades, the last slide for the blades, we have landfill blades. One advantage of landfill blades is that it are these openings. So can you make a guess why they are good? Because they can help the operator to view the amount of load, or the load that is in the blades. Okay, so it helps the operator to make better decisions or judgments. And stinger blades, as you can see, they are not symmetrical on one side. They have a cutting angle, and they can easily remove the trees using that angle. Alrighty, so there are 3 different blade operations. This one is called tilting, when you could move the blade up and down, and this is called pitching, where you could lift the blade, and without changing the angle of the blade, you could move it to right or left, which is called angling. So tilting, pitching, and angling. So let's see if we can identify them. So starting with this one, what is it doing? Is it tilting, pitching, or angling? So this is angling. What is this one? This is pitching, and this one would be tilting, right? So you could move them in different directions, and angling could be, I mean, you could get quite a big angle like this, depending on what you need. Okay, blade volumetric load. So one thing that is very important for us is to know how much load that the blade can carry. It depends on three factors: manufacturer's blade rating, it means what is advised, what is suggested by the manufacturer. It could depend on previous experiences. Usually a construction manager could identify that, and the field measurements. Let's have a quick look at what each one is. So number one was manufacturing blade rating. So it actually it is a relative comparison of a dozer blade capacity. You cannot actually predict the productivity, but by making some comparison, you can actually compare the capacity in different cases. So we're not using these equations in this course, but anyway, the way they are calculated, as you can see, it depends on W and H. W is the blade widths. Okay, obviously the wider it is, the higher would be the capacity. It should come in yards. H would be, so we have the widths, and H would be the effective blade height. Okay, so blade height. So if you multiply them, this will give you Vs, and obviously this is an like an adjusting factor, because you cannot use the entire surface, but in good cases you can use almost 80% of the surface. So if you have the Vs, which is called capacity of a straight angle, because straight or angle blade, if you have this, if you multiply, if you add it with this part, so what is Z? Z is the wing length measured parallel to the blade widths. Okay, so the wing length measured parallel to the blade widths. If you have this, and if you add it with Vs, then you can get Vu, which is the capacity of universal blade. So when we're working with dozers, most of the time, the type of volume we work with is loose cubic yard. All right, and previous experiences, if you have documented, you know, what the numbers you got in your previous projects, that could be very helpful, because they reflect your own, your own condition, your own machine, your own operator, so they are more reliable if you have collected them with precision. So they could be used to determine the total volume of material moved, and also it is necessary to record the number of dozer cycles if you want to. So yeah, if you have the total material that you have moved and the cycles, dozer cycles, then you can have an estimate of how much load you have moved in every cycle, right? So And field measurements. In field measurements, you should measure three things. You should measure the widths, measure the heights, measure the widths, okay? And measure the greatest length of the pile, okay? So, of the pile, not the blade, okay? So, you want to see what is the height of the load, what is the width of the load, so you can find the volume of the load that your blade can move. So this could be quite helpful because it can help you to find the estimated time it takes to get the job done. So when the operator is pushing the load or the dirt, you would go ahead and take some measurements, okay, and you do the math, simple math. So this volume of earth was moved in one time, so we have this volume. So by dividing the entire volume by the volume that could be moved in one cycle, you can find the number of times you have to do the pushing or the activity, and then by having how much time is required in each cycle and multiplying by the number of cycles, you can get a good estimate of how much time will be required to get the job done. All right, so let's talk a little more about dozer production. Yeah, there is no set volumetric capacity. It means no one can tell you that the capacity of the blade for this dozer is this much, because it depends on so many factors. Yeah, there is no hopper or bowl to load. Yeah, if you have a hopper, if you have a container like a truck, you could easily tell how much, what is the capacity of that. But in the case of dozers, it's different. The amount of materials that a dozer moves at a time depends on how much material is retained in front of the dozer blades when you're pushing those material. But what does dozer production depend on? It depends on earth material, obviously. The condition, the density can impact the production rate. Hull grade, like if you're working on a level surface, if you're going uphill or downhill, you will get different productions. Obviously, downhill gives you more production than uphill. Those are horsepower, how much power is created by the engine. Blade capacity, blade capacity is the maximum load that the blade can push, but most of the time not all of it could be used due to different reasons, such as the earth you're moving, type of earth you're moving, type of road condition, the grade of the road, and other items. And cycle time is another thing that dozer production depends on. It means you should see how much time it takes to push the materials from point A to point B. That obviously depends on the speed of the dozer. Okay, so let's get into a little more details about it. So estimating dozer production, dozer production are controlled by three factors: type of blade, type and condition of materials, and cycle time. So in order to know how fast you can get the job done, you should first identify these three items. All right, so typical dozer speeds, we have different speeds depending, as you can see, we have different speeds depending on the materials you're hauling, you're actually operating. For hard materials, it is slower. For loose materials, obviously they show less resistance against being pushed. That's why you could move loose materials faster, but the speed is still very low. I mean, like 2.5 miles per hour. But the return speed is a lot higher because you're not pushing the materials, and so you can make good estimates that how much time it takes to move the materials. So remember, speed is the distance you can move in any unit of time. It could be an hour, it could be a minute. Okay, so how much distance you could go in a certain time shows your speed. So many of the times we know the speed, but we are interested to know the time. Okay, so we know that we are moving with 2 miles per hour speed, but we want to know how much time it takes. So simple equation is that if speed is known and time is unknown, time would be distance over speed. Okay, so this is a simple logic that we will use to distance over speed. Technically, I am replacing these two in this equation. So remember, keep that in mind. To find the time that is required to do the job, you should have the distance, okay, and you should have the speed. By dividing the distance by the speed, you can get the time it takes to do, the time it takes to travel. So Dozer production has this equation. So blade load should be given. Efficiency is because not all of the time you're using the dozer it's being helpful. I mean, it is actually doing work. So it's usually a fraction of an hour, like 50 minutes in many cases. So then you should divide it by the total cycle time, and the total cycle time includes the time it takes to push the material, to return it, and the maneuver time. Okay, so let's look at this example together. A track dozer can push so this much material at a time, and the material pushed is silt. The average travel distance is 90 feet, and the dozer, so distance is also given to us. We probably need that to find the time it takes to travel this distance, and the dozer moves at a speed of 2 miles per hour. So right now we know that we can find the time it takes to do it because we have the speed and we have the distance. Pushing the load and 4 miles coming back. Okay, so it pushes for 90 feet, but it should go 4 miles when it is coming back. Pushing the load and 4 miles per hour. The speed is 4 miles per hour when it is coming back. So when it is pushing, it's 2 miles per hour. When it is coming back, it's twice bigger. It also takes the dozer 0.05 of a minute to maneuver around while coming back. What is the maneuver? It means it should turn and come back, right, which takes some time. So what is the production rate of the dozer in loose cubic yard per hour? Also calculate the production rate in bang cubic yard if given the Soll factor as 0.80. So there's a lot of information given, but the problem is in fact very simple. There is a simple logic to do these types of problems. First, you should find the push time, okay? How much time it takes to push the materials. Well, you know the distance of the travel, you know the speed of the machine when it is pushing. So by dividing the distance by the speed, you can find the time. Then you can find the production using the big equation in the previous slide. And after that, you should make some adjustments. First, you should adjust the volume to bang cubic yard, and then you should adjust for efficiency. So this is the push time as you can see. So technically what we have done again is dividing the distance by the speed. Okay, as you can see, this is speed. So when you're multiplying by the inverse, you're actually dividing it, right? So another thing we have done is that we have changed fit to mile by dividing it by 5 to 80. You're actually converting fit to mile, and then you divide it by the speed to find the distance, okay? And then you want it per minute, but the speed was given to you per hour, so you should multiply it by 60, and the number you find would be the push time per minute, which is which is 0.51 of a minute, almost half a minute, or 30 seconds. So once we have this, we have the push time, maneuver time, travel time, okay? If you put them, the summation of all of them is the denominator of the equation, and you have these numbers here because you have the volume and other things you need. So this would give us 450 loose cubic yard per hour. Now, you should consider the swell factor. Swell factor was given to us as 0.80, so this is swell factor. So we should multiply the number we just found by this number. In fact, we can, if we're talking about bank cubic yard, we can perform less work, because with loose cubic yard it was 450. When you convert it to bank, it's only 360. Another factor we need to consider is adjusting for efficiency. So the initial assumption was that we are working, the machine is doing work 60 minutes per hour, but in fact it is not. There is always some wastage of time for a variety of reasons. So regardless of the reasons, we could just estimate that 50 minutes in an hour is the time the machine is actually working. So 50 minutes in an hour would be the efficiency, so 50 over 60 would be 0.83. So 0.83 of an hour is the efficient time. So if you do the math, you should multiply 360 by 0.83 to adjust for the efficiency, and the number you find is that you can operate almost 300 bank cubic yard of earth in every hour using this. So let me see how many more slides I have, and if I can finish this. Yeah, there's a lot more. So let me see, I'm actually here. Yeah, we can finish this. So clearing racks. So let's take a look. They're super powerful things. So as you can see, they have the capability of grabbing and removing the small rocks or any plants and vegetation that most of the time exists on the field. So when you are mobilizing, when you're preparing the job, they come handy. So they usually have a center plate, which is this part, to protect the tractor radiator. So ripping is another big thing that dozers do for us. And if let me get my pen. So this is the ripper in the back. It loosens the material and it prepares it to be pushed or to be moved. But something to consider is that to ask yourself, can I rip? Because if you use your ripper on a hard rock or very strong soil, what will happen is that it will wear out, and you have to pay a lot of maintenance costs. Let me show another quick video. Oops. For ripping. So depending, as you can see, it can still create a lot of power on even hard surfaces like this one. And you don't, it's not always only one ripper. You could have 3 of them, which obviously creates more power for ripping. Yeah, I mean the shank. You could have 3 shanks, or you could have a single shank. So ripping production, as you can see, when the shank could penetrate significantly into the earth to create, to loosen the soil, and in that case, you will be exerting load on the surface. Okay, so in the last slide, there is, let me make it larger. Yeah, there is some equipment selection strategy, like in each case, based on the earthwork equipment type, what is the good choice, so you can take a look at it. This is not necessarily related to dozers, but I found this helpful. Especially, you can keep this later if you are, when you are on the job site. You can make good decisions only by using this chart or this graph. So that completes our lecture. On dozers. Next time we will talk about graders. Thank you for watching and have a good time.